That's right. You've been hearing it in your head. Jitter, delay, latency. Well, you know QoS is coming up. Find out more right here on IT Pro TV.
You're watching IT Pro TV.
We are jumping into QoS, quality of service. And if the terms jitter, delay, and latency have been scaring you, you don't have to fear any longer. Anthony Square is here to help us. Anthony, here we are. We are jumping into this topic, and most of us that have come from the CCNA level, we might have learned the terminology so that we could get through the exam. But then we said, I'll never have to see that again.
Yeah.
And Anthony is back again.
Yeah,
So
we're going to take a deep dive.
All right.
We are, and we're really going to make sure that we get this.
Great.
Okay. I love that your CCNA students are here, Ronnie. They know the basics. Let's go a little deeper than that. And by the way, at the start of this episode, I thought you were poking fun at me when you said jitter, because I've had like
6
3
monsters.
monsters and let's see, a very large coffee from one of the local coffee houses. Okay, first things first, I really always love to start here when we talk about quality of service. And that's what Ronnie was alluding to, and that is the evils that exist in the network that are ready to make people really upset. Most especially those people that are on voice over IP phone calls or that are watching videos. You know, we see in our network when we're watching our ridiculously high quality videos over the network, what do you see? You see some skipping, you see some jumping. And I always hear the production staff that we have, which are incredible here. They always say stuff like, hey, by the way, that's just our network. So in our defense, well, we probably don't have QoS set up here properly on the wireless. And that's where we're seeing challenges. And we'll discuss that in, if not this episode, we have a part 2 on QoS coming up. But here's the deal. This is an extremely important topic, not just for the voice over IP or the video crowd. This will impact a lot of what we're trying to do in enterprises. And let's face it, we're always starving for bandwidth these days, it seems. Gone are the days where it's like, oh my gosh, what are we going to do with this 50 meg WAN link we have at home? You know, now that's like nothing. I have 300 over 300 at my office in Tampa, Florida, you know, and that's not enough for what I'm trying to do. I'm shooting IT Pro TV episodes that are 3 gigs in size that I got to move around. So bandwidth's on short supply. We have delay called latency. Ronnie brought up the great one. This is the ultimate evil. Well, there's 2 that are the ultimate evils. Variation in latency, that's called jitter, and packet loss. Those are a nightmare for a lot of different forms of traffic, Ronnie. The variation in delay, the jitter, you see, early on they figured out there's things like propagation delay and serialization delay and processing delay. Those are different delays that are very predictable.
Right.
Okay? And so they figured out like, oh, no problem. We'll take care of this. We'll have a buffer. It reminds me of the old extended skip protection for those of you that are older like me that we had like on the Walkmans and the Discmans. And you could run and that CD wouldn't skip because it was actually playing you the music out of a buffer. So that's how they did the skip protection. Well, quality of service started like that. But notice that doesn't help you with huge variations in delay. If you are running like at 80 milliseconds round trip time, then all of a sudden you're 800 milliseconds, then you're back to 80, then you're at 300. Those variations, that's a real problem from a quality of service perspective. So we have all those potential nightmares. What are we going to do for a solution? Well, there's 3 overall approaches. And I love the first one. Don't do anything.
Yeah. Best effort.
Yeah, best effort. And that's actually not true. You do something. If that's your approach to QoS, oh, you're doing something. You're getting out the wallet and you are making massive expenditures on capacity.
Right.
Like my America wallet.
Like it. Love it.
This is non-leather. I was a vegan for 3 days, and that's how I ended up with this wallet. So I had to get rid of the leather one.
Of course.
Yeah. So you're buying a ton of bandwidth, Ronnie.
Right.
That's your approach.
Right.
You're good because you're not doing any quality of service configuration. You have to make sure there's way more bandwidth than you need. And that's just not practical in a lot of scenarios. So for most of us who can't afford to overindulge in bandwidth, we're going to do an integrated services approach or a differentiated services approach. The world has gone diff-serve. Integrated services does still have applications, but it is not nearly as widely used. Just so you know, the integrated services approach is really all about one protocol, the RSVP protocol. And this is where you're going to have signaling information sent forward in the path of the traffic that you want to give QoS to, and you do reservations for that traffic.
Okay.
And I can see from your expression,
Wow.
Ronnie, you're like, oh, that seems like a lot of work.
Yes.
That's exactly the issue with it. There's so much overhead and so much that goes into that process. Wouldn't it be smarter just to treat stuff with a special QoS treatment hop by hop?
Right.
And that's what we have with the differentiated services approach. The differentiated services approach begins by classifying traffic. We classify traffic first. We like to classify traffic as close to the edge of the network as possible. Let me even give you a better definition. We like to do it as close to the source as possible. So if Ronnie is sitting at his desk and he picks up his voice over IP phone to make a phone call, we want to classify it right there, right at the source of the traffic, if at all possible. And what could we use to classify it? Well, there's a whole bunch of different things you could use to classify your traffic. You could use QoS groups, which are internal to routers. You could use just an interface. Ronnie could say, you know what? All my stuff's important. Everything coming out of my workstation and voice over IP phone, it's all critical. So he could ask that his interfaces be the classification for his important traffic. You could do it by MAC address. Or you could have traffic that already has quality of service markings. This is the beauty of the differentiated services approach. Let's say we partner with some organization and they're like, hey, we have high priority transactional traffic that we need to send into you. We've marked it as high priority. Great. All we need to do is honor what's called trust their QoS markings, and then they will get the treatment that we want inside our organization. So the first step is classification. The second step is marking.
So when you talk about this idea of classifying as close to the source as possible, does that mean that all QoS implementations are going to be acceptable? In other words, does it matter in terms of brand or vendor? Do they implement them differently or anything?
No, that is an excellent question. The great news, Ronnie, is these are now standardized.
Okay.
So yeah, we've got the differentiated services code point that we can use to classify and also mark traffic. We've got the experimental bits inside of MPLS. Silly name, because now they're used for QoS. But when they were invented, they had no idea what they were going to do with them. Isn't that funny? There's IP precedents. I'll talk to you more about these. But these methods of classifying, and then we're, again, going to mark traffic, yes, they are based on standards. And Ronnie, great example is voice over IP traffic.
Right.
We now all agree across the whole wide world that we're going to mark that as expedited forwarding, a specific marking that that traffic gets, and everybody knows that the EF traffic is voice, and they're all treating it with care, and that's why voice over IP is a hit, one of the reasons. There's one on this list I wanted to point out to you, Ronnie. I haven't asked you about this, so this is,
Yeah.
live reaction here. NBAR. Have you played with NBAR yet?
I have not. I was
Okay.
going to ask you about that as well, because source destination IP look fairly
Yeah.
kind of logical. TCP, UDP, logical. NBAR, not so
Yeah,
logical.
what is NBAR?
And then what is NBAR 2?
I know. Hilarious. So I'm old school, and NBAR 2 caught me by surprise. Yeah, must be relatively recent. That's network-based application recognition.
Oh.
I'm close.
Right.
It's a little protocol analyzer that's built into your Cisco routers and switches. Yeah, so it's a little protocol analyzer, and you can tell NBAR like, oh, okay, what types of traffic are running, and you see, okay, web traffic, FTP traffic, gaming traffic,
Right.
voice over IP traffic. It will show you a snapshot of what's running for traffic on your network, and you could take that NBAR information and then classify based on it. So pretty cool that you have a little built-in traffic analyzer. NBAR 2 seeks to do it more optimally with the devices. So one of the things that we got to do clearly for this to work is we have to classify our traffic. What's the voice traffic? Are we going to prioritize that? Of course we are. What's scavenger traffic? What's traffic that we want to like take a back seat? If your company allows gaming, if your company allows Facebook usage while at work, those might be forms of traffic that you want deprioritized. What you want to do is mark the traffic so that based on those markings, each hop along the path can give the quality of service treatment that that form of traffic warrants. And look at this on screen here. The great news is we can mark at the we've got basically physical or internal with QoS groups. So 1 through 3, including MPLS layer 2.5, we like to joke, right?
Right.
So we have QoS groups, we have class of service at layer 2, we have the MPLS experimental bits at layer 2.5, and then we have IP precedence or DSCP at layer 3. What this means is it doesn't matter what layer you're working at the OSI, Ronnie, you have the ability to mark traffic to signify what classification it has.
All right, so let me ask this question now that you have this up here. Why would I choose, let's say, layer 3 versus layer 2?
Great question. So we would always want to DSCP mark. So the differentiated service code point is the latest, greatest way to mark traffic. It's what you always want to do.
Okay.
The only time you wouldn't do that is when you can't. And that is when it's a layer 2 switch, right? The layer 2 switch is like, I don't understand layer 3. All I know is layer 2. Okay. So I don't know why I'm doing a robot. The layer 2 switch is not a robot, is it, Ronnie? But what you would do is, for that little device, you'd be like, okay, little fella, mark what you can, and that's the COS. And then what you do, Ronnie, is that traffic goes to a router, right? You can then have the router go, oh, I see you did COS. Thanks, little switch. And then it can have a mapping table.
Okay.
You set up a mapping table on it, and it will map the COS to the DSCP and send it on its way.
So there's no conflict there if you mark something at layer 2 and then it goes to layer 3 and a different marking or a different thing happens.
Right. We have mapping tables that we use to do that translation. Yep. And now remember, you always have choice over whether you're going to honor the markings, what we call trust the markings that you're receiving. But in most well-designed networks, that's exactly what we do. I mentioned the IP phone, by the way. The IP phone, Cisco was thinking this through. When you pick up the IP phone and you make a phone call, by default, that traffic is being marked with DSCP expedited forwarding. So you have the markings taking place in an automated fashion. Very, very smart. So classification, marking, right? Simple stuff. Before we leave this concept, I did want to elaborate with you on some of those markings because we didn't go into detail on this. So The one that confuses everybody is the type of service section of an IPv4 packet. So there's this toss byte, we call it. Those 8 bits that make up the toss byte, in the early days of IP, they said, oh, I know what to do. Let's take the first 3 bits, leftmost bits, 7, 6, 5, those bits, and they will be for IP precedence. And this was perfectly in keeping with the 3 class of service bits used at layer 2 for for QoS markings. Great. But it didn't take long for the engineers to go, boy, we sure are wasting bits. You know, wouldn't it be great to give meaning to those other bits in that field? And that's what DSCP gives us. So the new and improved methodology that we've used for a long time now, actually it's not that new anymore, is the differentiated services code point approach. Notice it's going to use the 4 bits. So bits, wait a minute, let me make sure I get this exactly right. So you've got 4 bits to give the DSCP value, and then you have 2 bits utilized for explicit congestion notification, and then there's 1 bit that has another purpose that I didn't bother to list here. The bottom line is all the bits of the toss byte finally have meaning, Ronnie, and finally can communicate excellent information. So the DSCP marking gives us the quality of service treatment we want to do with much more flexibility than just the IP precedence approach. But notice there's explicit congestion notification. So now devices have a way to communicate. I'm super congested, you know, just slow down, you know, at the rate of which you're sending me information potentially. We call those the flow control bits.
Now, is there some overlap with that explicit congestion? Because it looks like it's 9 bits altogether.
Yeah, and I've confused myself on how I presented this. The DSCP bits incorporate the IP precedence bits because we can't have we don't have 9 bits here. So this is great. We have a part 2.
Right.
I'm going to elaborate on how these bits work out. But here's the great news I have for everybody as you look at this presentation. You might think, wait a minute, is it DSCP or is it IP precedence? And are those 2 compatible? Yes, they are. So there's this nice compatibility where if you have an older system that's marking using the IP precedence 3 bits only, the way they set this up, that plugs right into the DSCP marking system, okay? So Ronnie, don't let me forget to elaborate on how those bits line up. I do believe it's the first 4 are DSCP, and then we have 2 bits for a job I can't think of, and then the 2 explicit congestion notification bits, but we'll pull it up and we'll elaborate on it. The last thing we wanted to talk about in this episode is Ronnie mentioned standardization. Oh boy, is that happening more than ever. The differentiated service code point approach allows us to define kind of standard per hop behaviors. Remember what I said earlier in this episode. Voice always gets expedited forwarding. It gets this incredible priority. So notice there's a PHB, a per hop behavior that we dedicate to something like voice. There's the assured forwarding where we can say, okay, you're not going to get as much priority as voice, but you're going to fall in the higher priority stuff. There's the default forwarding behavior for like all unmarked traffic. There's a class selector per hop behavior. What's this all about? This is basically honoring letter for letter the IP precedence and class of service approach. It's like, okay, we're not going to do any fancy DSCP type stuff. We will just honor the 3-bit approach. So there's these per hop behaviors that help standardize this. Now, Ronnie, I want to wrap up this episode by saying this to you. While a lot of this technology is standards-based, remember how you classify traffic might be very unique.
Right.
For instance, I said gaming or Facebook, we're going to scavenger class those. Wait a minute. What if you work at a gaming company? Well, the gaming traffic is your most important thing. So I want to emphasize that how you classify traffic, that of course is up to you. But please give voice traffic expedited forwarding. As we'll talk about in the next episode, if voice doesn't get big time priority, it's not a good experience.
All right, Anthony, thank you for helping us this far. I know that you said that we have a part 2 coming up to actually kind of dive into it a little bit deeper. But in this episode, we did review the idea that we're really taking a look at differentiated services is what we're actually focusing in on instead of the other ones that we were talking about, as well as taking a look at the per hop behavior as well. Those are actually key elements that you want to make sure that you understand as we continue to move forward. And of course, the idea of latency and jitter and delay, all those are actually possibilities on definitions that, of course, you should be familiar with too. But there is more to come, so this is a great place for us to sign off. For IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.